Hi everyone, Charles asked if I could just go over some of the problems. So we're solving for dy dx in this problem. So in order to do that, that's just the derivative. I don't see any dy or dx to begin with, so just let's take the derivative. X plus y, no, I'm sorry, x times y squared plus x squared over y is equal to 5. That's going to be product rule, and this is going to be quotient rule, okay? So the derivative of x is 1, y squared. Derivative the front, leave the back alone, the derivative the back. Sorry. Leave the dy over dx, derivative chain rule, and leave the front alone. I forgot this the first time I did the problem, so I had to redo the problem. And then the quotient rule, derivative of the top, leave the bottom alone, minus derivative of the bottom, leave the top alone, all over the bottom squared, equals to 0. Now, I see the dy dx and they're buried, and now here's the part, that's algebra 2 that we have to use. So I don't like the fraction. I don't like this fraction here. So we're going to get rid of it by multiplying everyone by a y squared. Y squared, y squared, y squared, y squared. Y to the fourth plus 2y cubed dy over dx plus 2xy minus x squared dy over dx equals to 0. Then we have to isolate the dy over dx, and we do that by moving it to the other side. Y to the fourth plus 2y cubed. These guys both have a y, so we'll deal with that later. And it becomes a positive x squared dy over dx. And that looks nice. Dy over dx. And minus 2y cubed dy over dx. Now the trick here for algebra 2 is they both have a dy over dx. We can factor that out. X squared minus, x squared, x squared minus 2y cubed dy over dx is equal to y to the fourth plus 2y cubed. Then we're going to divide this whole section to the other side. So rewriting the top also, since I can factor that, be y left over y cubed plus 2y. Shoot, I've lost the x. It's x there. Lost the x. Did that before also. That's an x. And that's an x over here. And for some reason I copied this here incorrectly. That should have been, 2xy, we're left with 2x, all divided by x squared minus 2y cubed x. Now, none of these answers actually look like that, close enough, but with some moving the negative, that's my answer. This would have been taking out the negative x, then we're left with a positive 2y cubed minus little x, or regular x, and top is negative, we can move the negative on top. Y cubed plus 2x. Okay. We dealt with these boxes in a previous lesson a long time ago. The figure above represents a square sheet of cardboard with sides of 40 inches. So we know this is a square. Let me go ahead and edit this. So we know this is 40 inches, and we know this is 40 inches. The sheet is cut into pieces. The sheet is cut and pieces are discarded. When the cardboard is folded, it becomes a rectangular box with a lid. The pattern of the rectangular box with the lid is shaded in the figure. 4 squares with a side of x and 2 rectangular lengths are discarded from the cardboard. So that's these guys here. 1, 2, 3, 4, and the 2 rectangles. Those are discarded from the cardboard. Which of the following statement is true? Okay. Let's see what type of questions they're saying. The total is the volume. And let's see what the questions are. The questions are The figure above represents okay, when x is equal to 20, the box has a minimum. When x is 20, it has a maximum. Okay, so we're looking at the minimum and maximums, and which of these will be true? So to find the min and max of the volume equation is V is equal to L length times width times height. Let's see if we can come up with a calculation of what this would be. We know again this is 40. So let's call this another letter. Let's call this the length. This is the width, and this is the height of our box, right? Because if I fold this up, right, the box will look kind of like that. Right? So let's use some letters here. We know that the x is our height. Right? We know that, let's see, let's call this y, or let's call this y, sure, okay. So this is x, y is equal to 2x's, 40 minus 2x. Our width value here, I guess we call that, never mind. Let's just call that the length. Our length value, right? Our width is equal to, those are two w's. So this is 40, which is 2w plus 2h, right? Because we have two widths and two h's. That should add up to 40. And we also know that the height here is the letter x, right? So we can rewrite this as 40 is equal to 2w plus 2x. So the volume is equal to, let's see, is there any way for me to rewrite the width? Oh, whoops. Let's rewrite this. So solve for w is equal to 40 minus 2x over 2. Right, we move the 2x over and then we divide by 2. Dividing it, w is equal to 20 minus x. Alright, let's plug in everything that we know. We know the volume is equal to our length, which we said over here. Length was 40 minus 2x. Our width was down here, which was 20 minus x. And our height over here, which is equal to just x. The volume is equal to, we can multiply those together. Let's multiply it. It's going to be 800. That's going to be negative 40. And this is a negative 40 of x and negative 40x. That's negative 80x. Then plus 2x squared multiplied by x. The volume, rewriting it, is equal to 2x cubed minus 80x squared plus 800x. Okay. So to maximize or minimize this is we want to take the derivative of this. When does the slope, so the volume graph looks like this. The volume starts to increase, a positive slope, and the volume will start to decrease, a negative slope. So it changes from a plus to a minus, or if it goes down, it goes from down to up. It's a negative to a positive. And the slope right here is going to be 0. That's the rate of change that the volume is going to go through. A positive change or a negative change, then switch to the opposite. So take the derivative. so dv, I'm sorry, is equal to 6x squared minus 160x plus 800. And we can try factoring that. Let's see if I take out a 6. No, I can't take out a 6. I can take out a 2. 3x squared plus 80x plus 400. And our values can be factored to become 3x, x, and 20 and 20 plus and plus. That's 20 and 60 becomes 80. So our values are x could be negative, oops, I'm sorry, I messed up right here. That was negative, 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 and that's negative and negative. So it's going to be positive 20 over 3 and 20. We draw our number line at 20 and 20 over 3. Let's see if we pick a number that's bigger than 20. If I check it here, if I plug in the number bigger than 20, that looks positive to me. Let's see, 21, that's going to be a positive on the right, and that would be 63, that's going to be positive. That's going to be positive for us. Number a little bit less, let's say I pick 19. 19 would make this guy negative, and 19 would still make this guy positive. So we're going to be negative. If I plug in something a little less than 19 over 3, this will give me a negative and a negative, that becomes a positive. Okay, so we know we're going to go increase to decrease and decrease to increase. Now let's go back and look at our possibilities. So remember, 20 over 3 is a max and a minimum at 20, okay? So we said from before, 20 over 3 was a plus minus plus, right? So we have a maximum. No, we have a minimum. Oops. The problem is, are both these answers valid? Because we see the answer here, that's a minimum, right? And this is a maximum. So which of these are right? Well, let's go back and look at what we wrote previously. Let's see, did both these values actually work in our original function? If x was 20, okay? If this is 20, then isn't this also 20? And so we're way over our value already. So there's no way that our x could be 20, right? If x was 20, sorry, let me show you here. If x was 20, remember our width? That was the equation for our width. If that was 20, 20 minus 20 is 0, so our width would be 0. That would make no sense. So our real only answer here is our 20 over 3. So go back, and our answer really is only this guy. Maximum possible box here.